In this video, you will learn the concept of resultants, its types, and the vector representation of forces. We will also know how to find the resultants of forces that passes through the same line of action. A resultant is produced by an unbalanced force system. If the force system is unbalanced, it will change the object's state of motion. Consider a box placed on top of a floor. A force 1 pushes it to the right, and another force named force 2 pushes it to the left, and these two forces are along the same line of action. Based on the length of the arrows, we can say that force 1 is greater than force 2. Therefore, the force system is an example of an unbalanced force system. And since it is unbalanced, it will produce a resultant. Now the resultant is just equal to force 1 minus force 2. This is considering forces going to the right to be positive and forces going to the left to be of negative sign because they are acting on the opposite sense. Thus, we have your resultant. And resultant forces or unbalanced forces changes a body's state of motion. From our computation, we have determined that force 1 minus force 2 is equal to the resultant R. This is an example of equivalent force systems. It is said that two force systems are equivalent if they will produce the same external effect when applied not simultaneously on a body. Thus, the resultant is the simplest equivalent system of a force system. Let us now differentiate the different types of resultants. The first one would be a single force. From our previous example, the resultant that we have taken is an example of a single force resultant. The next one would be a couple. A couple basically is composed of two equal magnitude, non-collinear, parallel forces of opposite direction. The next one would be a force and a couple. Now this one is composed of two unequal magnitude, non-collinear, parallel forces of opposite direction. The resultant of force systems may be a single force when you are taking the resultants of collinear and concurrent force systems. However, the resultant may be a couple or a force and a couple when you are taking the resultant of forces in coplanar force systems. We will be discussing these types of force systems in the latter part of this video. Composition is the process of reducing a force system into a simpler equivalent system. On the other hand, resolution is the process of expanding a force or force system into a more complex equivalent system. So basically, resolution is the opposite of composition. A component of a force is one of the two or more forces into which the given force may be resolved. We will be using the concept of components later on in the discussion of resolution of forces. The anti-resultant or the equilibrant of a force system is the simplest force system that will balance the given system. In the case of a resultant, it will have the same magnitude and line of action but will act in the opposite sense. Collinear forces are forces acting on the same line of action regardless of their magnitude and sense, while concurrent forces are forces acting on the same plane and meets at a common point. And lastly, coplanar forces are forces acting on the same plane. So these are basically two-dimension forces acting on the same plane. A vector may be represented using directed straight lines or arrow lines. Thus, a force may be drawn as a straight arrow line that is collinear with the line of action with its magnitude as the length of the line according to a desired scale, and its direction is to be represented by the arrowhead. If a vector force will be represented with its magnitude and direction only, that is parallel to the line of action, it is called a free vector. If in addition the line of action is to be considered, meaning the force vector is collinear with the line of action, then it is referred as a localized vector. Let us try to use the principle of vector addition to find the resultants of collinear forces. We have here a box that is placed on top of a room or a floor. We have one line of action, and the force 1 equal to 3 newtons is pushing the box to the right, and the force 2 that is also pushing the box to the right of magnitude 2 newtons. To find the resultant, we will just add the values of these two forces considering its direction. The resultant now is equal to force 1 plus force 2. Let us consider forces going to the right to be positive. Thus we have the resultant to be equal to 3 plus 2 newtons. We now have your resultant equal to 5 newtons to the right. Consider another box, the same line of action, and force 1 equal to 3 newtons pushing the box to the right, and a force 2 pushing the box to the left, that is having a magnitude of 2 newtons. To find the resultant, we will just add the values of these two forces considering its direction. Just like in our first example, we will consider forces going to the right to be of positive value. Thus we have the resultant to be equal to 3 newtons plus negative 2 newtons. The negative sign accounts for the direction of force 2 that is going to the left, opposite to the consideration that we have made that forces going to the right should be positive. Thus we will have the resultant to be equal to 1 newton to the right. Considering the same box and the force 1 that is pushing it to the right equal to 3 newtons, and another force 2 equal to 3 newtons that is pushing the box to the left. To find the resultant, we will use the same process. R is equal to F1 plus F2, but we will still consider the direction of each forces. Thus we will have the resultant equal to 3 newtons plus the negative 3 newtons. The negative sign, again, denotes the direction of our force 2 because we considered forces going to the right to be positive. Thus we will have the resultant to be equal to 0 newton. This is an example of a force system in equilibrium state along the horizontal direction. Finding the resultants of collinear force systems is simple, as we have demonstrated in the previous examples. For our next video, we will learn how to find the resultants of concurrent force systems using the parallelogram and triangle law. Thanks for watching. If you like this video, don't forget to hit the like and subscribe button and turn on the notification bell.